All right, well, welcome everybody to Solar Noon Tuesday. And as is our normal habit here, we're going to go ahead and start with the news of the industry for this week. And then what we'll do is I'll try and highlight some of the events that are coming up, some of the webinars, a little bit fewer than normal this time because it's December. Everybody's figuring nobody's paying attention in December, which reminds me, I'm planning on not doing these sessions during the month of December. I've got to actually rewrite a textbook, so I'm going to focus on that. And I figure everybody's out playing in the snow. So we'll start again in January, but during the month of December, we won't be doing these sessions. I'll try and send a reminder on that. Okay, so in the news, according to this new study by CEA, the raw materials for production of batteries, regardless of the type of batteries, but they're speaking specifically of lithium ion, will be the major impediment to creating a domestic battery industry here in the US. There is apparently quite enough of the phosphorus and the lithium to make the battery industry viable here in the United States. The problem is some of the other materials, and specifically they were calling out graphite. Now, I hadn't really realized it, but apparently graphite makes up about 50% of the materials within a battery by weight, regardless of the type of battery, either lithium ion or lead acid. And most of the world's reserves are in countries like Turkey, China, Brazil, even some African nations like Madagascar, Mozambique. So we may have difficulty in the supply chain since everybody's chasing down these raw materials. Currently, the global capacity or use of batteries is at about 670 gigawatt hours of storage capacity, and they're anticipated that's going to increase by 2030, which is only 7 years in the future, up to over 4,000. So many times what currently is. Just for storage, because a lot of these are going to be part of EV through the EV industry, storage globally about 60 gigawatt hours, that's going to increase to about 840. Currently, the US has manufacturing capacity for about 60 gigawatt hours annually of manufacturing capacity. And if you look at all of the announced factory openings, that's going to increase to over 1,400 by 2030. So if that's going to happen, we're going to have access to those materials. Currently, utility scale storage. So this still sticking with storage. We're kind of on a storage theme here today. Is for wind and solar. So storage associated with wind and solar systems is at around 9 gigawatts. Standard & Poor's Global or S&P Global projects that this is going to grow to about 40 gigawatts in 3 years, by the end of 2025. And we've seen a lot of activity. Well, California has mandated that all commercial buildings must be designed to incorporate storage. And the Texas grid is growing. They're installing wind and solar at a tremendous rate. So the projections are that 2/3 of all of the storage capacity that's going to be installed in the US is going to be installed in those two states, in California and in Texas. So while the storage industry is booming, it's going to be booming in very specific geographic locations, California and Texas primarily, although Nevada is also going to be a hotspot for storage. So those are the big three. A lot of the states are trying to build their storage capacity in their storage industry. And when the IRA, the Inflation Reduction Act, was passed, it changed the way that storage tax credits associated with storage can be used. Used to be that it was only tax credit worthy if storage was in conjunction with a generating facility like wind and solar. Now it can be done as a standalone. The significant thing there is that it means it can be independent or located closer to where the loads are being used, not where the power is being generated. So 10 states currently have storage goals set at the state level, and these are California, Nevada, Oregon, Illinois, Virginia, New Jersey, Connecticut, Massachusetts, New York, and Maine. Okay, so that's where the states are at least trying to boost the industry. There's a new study by the Brattle Group, and they found that community solar, and just to repeat or to refresh people's minds, community solar is where instead of installing solar on your rooftop, you buy into a larger solar array and then you own a portion of that solar array. Well, they did an economic study and found that actually putting community solar projects on top of urban commercial properties and warehouses is much more economically viable than putting these things up on open rural land. For a lot of reasons. In fact, what they're finding is using the warehouses and the commercial structures for solar and storage can save as much as, well, between 4.39 and 9.05 cents per kilowatt hour for the ratepayers. This is showing you like 6 different evaluations. So that's the high end and the low end on those ranges. Not only does it save money because the process and the approvals and the build out is faster in these developed areas, but it reduces transmission and distribution costs. And it also has the added benefit of reducing, keeping more open lands out there as opposed to using them for solar. And to talk about capacity, for example, California has about 66,000 eligible commercial roofs for this kind of thing, which is enough to power about 4.9 million homes there in California. So a lot of capacity there. So interesting way to look at how community solar could be developed. And Enphase just announced this week that they're launching a new microinverter that's designed for the commercial, small commercial industry. They're calling it the IQ8P-3P, very catchy name. It has peak output of 480 watts. That compares to the IQ8 Plus, which I think is at either 290 or 300 watts in there. And it supports 3-phase power. It's compatible with solar panels that range in size from 320 watts all the way up to 640 watts. Now, I've never seen any 640 watt panels, but apparently they may be out there. I don't know. But it does require its own unique gateway. If you're familiar with Enphase, they have a communications gateway. This you'd have to install the IQ Gateway Commercial 2 with this system. And they're also rolling out with this microinverter a new feature that I suspect is going to be incorporated in other Enphase products, calling it the Enphase Burst Mode. And essentially what that means is it'll operate under lower light conditions so that the array will begin to produce power earlier in the morning and later into the evening in low light levels. And that was pretty much the news that I had for this week. Does anybody have anything they want to add to that, that group before I get into the announcements there for this week? Anything that you ran across?
Devon, here. What about storage being utilized for as a peaker plant type of solution? Did that ever come across any states?
Yeah, what he's saying is, can we use storage as a peaker plant? Basically, my understanding of how peaker plants work, and they've been traditionally natural gas in the past, is during peak load events, you can just sort of fire them up. Is that what you're getting at there, Devin? And you can meet the load demand of the utility for brief periods of time. Yeah, I think utility system is actually starting to incorporate storage primarily for that purpose. They're using battery technologies so that when they do have these short-term peak demand loads, they can meet that from their own battery storage. And if you start looking at the statistics from the Energy Industries Administration, they're actually starting to put battery as one of the generating technologies out there. So you see them with wind, solar, coal, natural gas, battery, nuclear. So it's really being considered a generating facility all on its own. Some of the discussion that's out there at the moment is, what is the longevity? What's the length of time that's necessary for these plants? And it has always been very short term, minutes or maybe up to an hour. Well, now they're talking about 4-hour battery capacity. And in fact, I just heard a webinar about 4 days of capacity. So these long-term where you could use batteries as a generating facility for long periods of time. So I think we're going to start seeing that happening and expanding more and more. All right. Any other comments there? Let me hit the news, and then I'm going to ask. I had Jay and Pete, who had a couple of items they wanted to bring up. So the announcements for this week is on November 24th. That's that's already passed. Enjoy that one. All right, November 30th is coming up. Women Working in Sustainability. This is through the U.S. GBC, the U.S. Green Building Council. So that's an event that's coming up. And CEA, the Solar Energy Industries Association, on December 5th is talking about how to integrate the various construction trades on site. December 6th, we're looking at a webinar about 800-volt string installations. So that's going to be larger scale systems that are dealing at the 1,000-volt kind of range as opposed to residential. December 7th is sort of a forward-looking, what are going to be the risks and opportunities for the solar industry in 2024. So that might be kind of interesting to take a look at. And then, of course, there's a conference coming up in early January, mid-January in San Diego, the Intersolar North America and Energy Storage North America. So that's an actual physical in-person type of event. And then, of course, we have our classes and online and in person that are at solar. What is our website? solarpvtraining.com. So that's always available to you. And as I said, there are just quite a number fewer of these events happening in December. Let me jump in there. Jay, you had brought up the question before we got started about integrating generators.
Yeah. And just a friend who has a Generac and wants to add solar.
Yeah, and my understanding, well, first off, Generac is getting into the solar industry. So if he's wanting to add solar, he might want to talk, if he's really focused on Generac, they do have solar options, solar inverters, battery integration. They're trying to get into solar in a big way. So I would assume there would be no compatibility issues with his generator if he's using their inverter. So that's one thing to look at. But the things that I've seen or read with generators, normally the way it works is when you integrate in a generator, it's set to recharge your batteries as soon as they reach a certain level, a certain depth of discharge. And they then will recharge the battery. And then the battery, of course, is what's providing power to the home. So, but that all goes through the inverter. And so most of the inverters today, most of the smart switches that are either built into the inverter or independent of the inverter have a place where you can hook up a generator. But the generator has to be of sufficient quality because that generator, you don't want it damaging your equipment. So it's not something you can go down to Home Depot and get one of those little portable generators and hope that it's going to work, because you might get lucky, but it might also cause some problems. There's the other issue, and I'm trying to remember, there was a long article I read about this at one point where there is the risk of damage if this generator is providing too much power. So there's a lot of compatibility issues. And the recommendation of this particular installer was, don't use the generator to recharge your batteries. Use it to run everything if the batteries go below a certain level. So basically disconnect your solar array, your whole solar system, and run off of the generator if you've gone down, in an event where your batteries are no longer functional. So that was his recommendation. That way you're not going to risk damaging, backfeeding through and damaging your inverter or damaging any of this very expensive equipment that's part of your system. But of course, that has to work through your auto transformer or your disconnect, because you also don't want to be backfeeding the grid as well when that thing is being used. But this was a couple, maybe a year or two ago that I read that article, and I think a lot of the manufacturers are getting smarter about this kind of thing. So that may or may not be an issue anymore. But for sure, check with your solar inverter company and the smart switch company to make sure whatever generator you're working with is going to be compatible. That would be my only thing there. Does that sort of answer your question, Jay?
I'm sure it will. I'm going to ask Dale whether I will run this past him, see what he thinks.
Okay. All right. And Pete,
Jay,
yeah.
I have some dealers with Generac. Generac did look into produce a DC power generator to use with their inverter systems. And it was producing DC, and it was really taking DC through the inverter to convert it to AC, and also be used to charge your battery bank while keeping up your loads in your house powered. I don't know what was the outcome of that, but I know that was one of their product launches to create their own generators to work with the system. And being a DC power generator, it was supposed to mitigate some of the issues and challenges trying
Was
to
that
integrate that too.
was that Generac, did you say, was doing that?
Yes.
Oh, okay. That's interesting that Generac would be producing. I've not heard of a DC generated, DC power generated from a generator. I mean, obviously a generator is going to generate AC power,
AC, yeah,
but it will have to then be
rectified
back into a DC current. So that's kind of interesting. Okay, so Pete, you had brought up an issue about a project that you're working on there and wanted to see if anybody here had any specifics to
Yes.
help you with.
Yeah, so what I'm showing on the screen here, this is a Solar Direct MPPT controller that I've developed and have been using for many years. Others here in the La Crosse area are running them as well. The project is at a level of development where it's time to give it to the world via the Arduino's project hub. The catch I have here, is I'll show you the back of the board, is I've made my circuit boards on a CNC milling machine, and people don't do that. They use what are called Gerber files, which is an industry standard thing. And I'm looking for someone who's sympathetic to the cause to help me translate from Mechanical Design CAD to Gerber files. Either do the work for me or guide me or whatever. But the idea is this needs to be given to the world because we all have sunshine and we all want hot water. So a pretty good matchup is to ditch the solar thermal and use the solar electric and the bottom element of our commodity water heaters for a solar hot water system.
So you're saying that this project, this particular item, is taking solar energy and converting it into AC directly for the element?
No, DC direct to the water heater.
Oh, okay. So you're using a DC element in your hot water heater.
Right. And all the elements work equally well on AC or DC. There is a question of the resistance. But the big thing that it does is it just lightens the load so that when it's other than noon on a sunny day, that the voltage of the PV array is not dragged down unnecessarily and thus reducing power. So that's the MPPT part of the circuit. Otherwise, it's straight DC to the element. So there aren't a lot of components on the board. There don't need to be. So it is an ideal DIY project, but not that many people are going to sign up to make a circuit board on their CNC milling machine. They're going to want to send files to a board manufacturer.
Yeah.
Okay. Is that 24 volts? Asking.
No, it runs on pretty much whatever voltage you want, but I encourage people to stay either close to 120 but below it, or close to 240 but below it.
So even though it's DC, you're still operating at the 240 or the 120 volts?
Yeah, exactly, or something close to it.
Oh, okay.
Resistance heating elements aren't fussy, but what I point out to people is if your system runs at 160 volts, well, now you'll be using a 240 volt element, but with very low resistance, because that's all the voltage that you have can push through. So that's why it's advantageous to be something close to as I say, 200 to 240, 100 to 120, something like that.
So if you're running at that voltage, you don't have to actually change out the elements within your hot water heater at all?
You don't have to, but you may elect to if it turns out that at noon on a sunny day, it's actually on a quarter of the time, something like that.
Mm-hmm.
And it can do that. It's designed to do that. That just means more amps over shorter periods of time versus under the most ideal conditions being on something close to 100%.
Are you doing this, or do you envision this with grid-tied systems or just standalone systems?
This is intended to be standalone, adopted anywhere people want to take a hot shower and they have sunshine.
So it's like a
No
load
reason.
dump. It's like a load dump for your system as well?
Well, it can be, but more likely it's just a standalone system that heats water first and then diverts to space heat right about now when that's advantageous and the water is up to temperature.
Okay. All right. Well, that's great. Hopefully somebody out there is going to be able to get in touch with you. And if you want to get in touch with Pete directly, I guess just for ease, since this goes to video, you can just send me an email and I'll send it to Pete. My email's j@bluerockstation.com. So I won't put yours out there, Pete, because you'll get all the crazies contacting you. So
All right. And then when this is up on the projects page, I will impose on the viewers to check it out so that I can show that it has been revealed to the public and then may not be patented by other people.
Oh, okay. All
Because it is
right.
my intention to give this to the world.
Good enough. Well, you're safe with me because I haven't a clue how you're doing those things, but so all right. Yeah.
Yeah, I'll just say that to Peter. Everything is Arduino based. So I mean, Arduino means to me that's low cost. I think that's one of the key idea I get it in my mind at least.
Mm-hmm. Good. All right. So anybody else have anything before I jump into my rant and rave against the hydrogen economy? That was going to be my talk here today. And I know I see Tim Chavez on the call, and he told me I should smile more when I'm ranting against these things. So who knows? I'm not as upset about hydrogen as I was about nuclear. So maybe I'll be nicer. But okay, so let me talk a little bit about the hydrogen economy. And the reason I brought this up is because I'm getting a lot of things crossing my desk all of a sudden about hydrogen, seeing a lot of hype about green hydrogen. And as per usual, as I'm ranting here, why don't you guys feel free to just jump in or raise your hand or whatever, and if you've got a comment. But let me recap I always like to say around hydrogen that hydrogen is the technology of the future and always will be. It's like when you look back historically, the 1970s, there was hype in the newspapers about hydrogen economy is only 15 years in the future. And then you get into the 1980s and the 1990s, and the hydrogen economy is only 15 years in the future. And we have these conferences. And then, of course, today, the hydrogen economy is only 15 years in the future. It's always 15 years in the future. It just seems like that is the nature of hydrogen. So what's the hype? What's the promise? What are we looking at here? Part of it is I wanted to just kind of see what is the cumulative production of hydrogen, because they've been hyping it for a long, long time. You can sort of see that it was flat for a long period of time. And now recently, just in the last few years, we've seen it ramp up a little bit. Although these are pretty small numbers compared to what other energy sources are dealing with. But a lot of this is happening based on governmental incentives. So countries like Australia or the UK, they start to pump a lot of money into the hydrogen world. The US is pumping more money into it at the moment. And just like small nuclear, it's kind of an industry that's chasing after government funding, where a lot of the activity takes place. And here in the US, our government spending has been relatively stable for a good long period of time. It dipped down a little bit. Now it's starting to go up a little bit again. and I think that's kind of interesting that if you look over the last several decades, there's been a consistent, pretty expensive hydrogen program with nothing to show for it, and while that may be the nature of some research projects, I will argue that the very nature of hydrogen makes it an unlikely candidate for success. So, and I will also further argue, waiting for the opposition, that it is actually a fossil fuel industry, and that much of the government funding has been in place to support big agriculture. So it's basically been subsidy programs for the fossil fuel industry and a subsidy program for the Monsantos of the world. And that's why we see this consistent government funding, but it's posing in the garb of, isn't this wonderful? It's a renewable technology. Well, it to this point has not been. So that's part of my ire there. It's going to be big, of course. This is what they always say, as you saw what we have seen historically as far as the production. But here, this particular graph is projecting out into the future. So it's one of those, what do they call them? A hockey stick curve kind of thing, where it goes along flat for a long time, and then it's just going to shoot up because magically we all love hydrogen, and that's going to happen. But even in this graph, that is one of the most optimistic that I saw, the parts that are in yellow there are the renewable energy part. The rest of it is all fossil fuel stuff. So even when they're giving you the rosy scenario, it's still mostly fossil fuels that are going to be the source for hydrogen out there in the future. And what are the technologies that what are the things that they're saying hydrogen will be used for? Well, in this particular graph, heading off into the future, they're anticipating that hydrogen will have a significant use within industry. Specifically, when the things I've read, it talks a bit about, metals, steel industry, aluminum industry, things that require a lot of energy, a lot of energy density. They talk about power generation. To me, this is like one of the dumbest arguments, but they're saying electricity can be generated from hydrogen. Well, yeah, it can, but not economically and not compared to other alternatives. Then, of course, transport's a big thing. They always talk about that. There have been fits and starts around the hydrogen economy. There are some issues around transport, but I would say if you really are looking at transportation, the only two viable ones that may or may not be, a thing are going to be trans-ocean shipping and airplanes, because the need for energy density on an airplane is substantial. You've got to have a lot of power in a very light, compact area, and batteries, at least current battery technology, just is not sufficient. Then that's kind of where they're at. The hype of the hydrogen industry is we're 15 years away from these technological breakthroughs that are going to make hydrogen a viable technology for transportation, for power, for industry. Just give us more money, please. So that's kind of where they've been at. So where are the current uses for hydrogen at the moment? Well, this one here, it's kind of funny, but 55% of hydrogen is for ammonia production, which is primarily fertilizers. That wasn't even mentioned in their forward projections. It's like, what's the deal here? You're using more than half of it right now for ammonia. Seems to me that might continue into the future for a wee bit of time. But that wasn't there. Petroleum refinery, that's a quarter of the current hydrogen. And then, of course, methanol production. And then 10% is other stuff, the stuff they talk about. So 90% of the use of hydrogen is either big ag or fossil fuel. that's currently what the reality is. Not what they're talking about, but what the thing is, what it's doing at the moment. Oh yeah, Pete, you had a comment?
No, I'm live. Jay, the energy density per unit volume on hydrogen is rather low. So space critical things like aircraft probably won't succeed with hydrogen, but trains might.
Yeah.
And then the other interest in hydrogen for generating electricity is for seasonal storage, that they can store perhaps a few million cubic feet of hydrogen more readily for seasonal storage than batteries would allow it. But other than that, you're right, the economics aren't there generally.
Right. And I agree. But I mean, just as an example, the space shuttle has used hydrogen as a fuel source. So yes, if you just use straight hydrogen, it's not, but it's got to be, cryogenically frozen and severely pressurized in order for it to be, to get the energy densities that you're requiring. And the seasonal storage issue, well, there's a storage and a transport issue with hydrogen, but I would think that there are better other alternatives for that seasonal storage. An easy one that comes to mind is simple water. That's kind of what we're dealing with at the moment in the grid. That's the number one storage mechanism at the moment. But that's geographically restricted in some respects because you need changes in elevation for that to be effective. But there's lots of flywheel technologies. There's, lots of technologies for storing. Question is for how long? The different types of hydrogen. This is something that you're going to run across if you study hydrogen at all. Is the different colors. They love these color codings. And this is the main ones, gray hydrogen. This is hydrogen that is created using natural gas. So the hype that we always hear about hydrogen is all you need is water. And through electrolysis, you're going to create hydrogen, H2, and oxygen, O, right? So this is a beautiful technology because you end up with hydrogen, which is a power source, and the only pollutant that comes off of this is oxygen. That's true. That's green hydrogen, electrolysis. That's the one there on the right. But it is, as I will point out here in a moment, pretty energy hungry to create hydrogen that way. The more common way they do it is using methane or natural gas. And I don't remember what the chemical composition of hydrogen is. One of you guys might know, but it seems to me it's something like let's say C2H6O6 or something like that. Anyway, the bottom line is there's a lot more hydrogen in the methane than there is in water. And also the thing that you're going to be giving off is CO2. So it is a greenhouse gas emitting process. Blue hydrogen, that it sounds better, but it's really just natural gas under another name, where they're claiming that they're going to be storing the carbon capture. Okay, I see Pete just said it's, what was it? CH4 is methane. Okay, so black hydrogen, that's making hydrogen out of coal. That's always a good option. Pink hydrogen is when you make it out of nuclear power. Another good option. Then there's another turquoise. That one I don't run across very often. That again is another natural gas process. And then there's yellow hydrogen. I've never seen that except on this graphic. They usually lump that into green hydrogen. So, and the two that you're running across most of the time are going to be gray hydrogen, green hydrogen. So, but what they talk about is green hydrogen. So what are they actually doing? This is how hydrogen is produced today. 96% of the hydrogen on the market comes from fossil fuels, and 4% comes from renewables. So not only is it producing things for the fossil fuel industry and big ag, but it is also generating hydrogen using fossil fuels. And those fossil fuels are primarily natural gas, of course, almost half of it natural gas, but there's oil and there's gas, what is it, coal gasification. So all of those things. So my guess is one of the reasons we've seen substantial subsidy for hydrogen is it's the fossil fuel lobby. It's using their materials, and they're very effective at lobbying. I guess that's their thing. That's fine, except that it's always posing as a renewable energy source. And it clearly has not been to this point, although technologically it could be, in theory. So what are the barriers to moving forward in a hydrogen economy? Well, cost, I'll touch on that in a minute. The efficiency of the generating process for hydrogen versus the energy that's the result of that process. Storage issues, transportation issues, safety issues, lack of standards within the industry, and then, of course, competing technology. One of the things I like to say in my classes is, you know what? Well, something's going on over here. Get my hands there. Something else is going on over there. So anyway, so people who study one thing always just focus on that one thing, but something else is happening over here that's going to impact it. So the rest of the world is never steady state. So they're talking about, okay, well, if we can bring down the price of hydrogen, then it's going to become competitive. Well, guess what? The price of everything else is being brought down at the same time, and is always coming down at a faster rate than hydrogen. So what are the actual costs at the moment? And this is not so easy to track down. I was looking all over the place, and you get things that are all over the place as well. But the levelized cost, I kind of settled in on Bloomberg as my source for levelized cost of energy. And if we compare, they said that the cost of generating hydrogen is effectively, they don't measure it in kilowatt hours, they measure it in what is it, in liters, I think. But 1 liter is essentially 33 kilowatt hours, or sorry, 1 kilogram, not liters, but 1 kilogram is 33 kilowatt hours of power equivalent. So the equivalent cost for hydrogen they're claiming is 15 cents per kilowatt hour. That's the generating cost, but that's of all hydrogens without factoring in any of the externalities of pollution and the like. When you talk about green hydrogen, the cost goes up to about 33 cents, which is what they're always marketing anyway. You compare that with some of the other current technologies. Nuclear runs about 20 cents a kilowatt hour. Lithium batteries, just battery storage, which is considered very expensive at the moment, is 15 cents. So it's half the cost of green hydrogen right now, and getting cheaper faster than green hydrogen. Coal, 11 cents, natural gas, 8 cents, wind, about 4.6 cents a kilowatt hour, and solar about 4.5 cents a kilowatt hour. So looking down that list, hydrogen, not competitive. When we look at what they're projecting on the high end, here, those lines up at the top, that's the price that they're projecting it'll come down over the next, 30 years? So really they're saying, okay, right now it's 5 cents a liter, but it'll get down to around it's not 5 cents, $5 a liter. It'll get down to about $3 a liter if electricity remains at about, what was that? What's the price point there? I'm looking. It seems to me it was like 6.5 cents a kilowatt hour. Then they say, oh, you know what though? If electricity comes down to 2 cents a kilowatt hour, then we can do it, and then it's going to be price competitive. And I'm thinking, all right, but if it's 2 cents a kilowatt hour, that means every other form of energy is that much cheaper. And now you're just not competitive in that new environment. So, that's, anyway, this is, as Mark Twain said, there are lies, damn lies, and statistics. So this is the statistics part of it. So what are we doing when we compare that with battery technology? Well, right now, lithium-ion batteries are at about 8 cents a kilowatt hour compared to 18 cents as we move forward. So, and the price or the break point, this was the 2030 number. So even projecting out 2030, given their optimistic expectations, green hydrogen is going to drop down to 18 cents, but lithium ions are going to drop down to about 8 cents. So still going to be more than half the price. And if you're looking at it as a storage mechanism for electricity, why would you pick something that's twice the price that has all these other external problems compared to lithium ion? Lithium ion has some external problems, but transport and storage is not one of them, which we'll get into here in a second. Another thing that I think just is a killer right off the bat, I mean, you wouldn't have to go any further than this, is that under electrolysis to make green hydrogen, it says it requires, and then I found this in a number of sources, 39 kilowatt hours of energy to produce 33 kilowatt hours of energy from hydrogen. So it's a negative process. The power that you're using to create the hydrogen is greater than the power that is contained within the hydrogen at the end of that production cycle. So it's a little bit like ethanol. You know, ethanol takes more energy to produce the energy that's in ethanol from corn. That's a political thing. But here you're saying, okay, for every 39 kilowatt hours in, you're going to get 33 kilowatt hours out. Okay, well, that's dumb. That's if it's 100% efficient, but right now it's not 100% efficient. So it's currently about 48 kilowatt hours in, 33 out. So it's a net loss. Using it for electrolysis, that's converting water into hydrogen. Storage issues. Okay, storage, as Pete pointed out, hydrogen is very, I mean, it's the smallest atom there is. You know, so it tends to leak through metal containers. It dissipates. It actually boils off into the atmosphere at minus 252 degrees Celsius. So it's got to be maintained at temperatures colder than minus 252.8 degrees Celsius. So cryogenically frozen, stored under very high pressure tanks of 5,000 to 10,000 pounds per square inch. You know, that's a lot of pressure and a lot of energy just to maintain and store. So if you're talking about it being used as a long-term storage energy storage device, you got some serious energy inputs just to keep it in play. As a good example here that I like is the NASA. You know, NASA's got some pretty intelligent engineers there, but they use hydrogen for the space shuttle. And it turns out just fueling the space shuttle, they lose 46% of all of the energy from the hydrogen in the process of fueling the space shuttle. So when they're moving it, when they're storing it, when they're transferring it from the storage tank to the space shuttle. So for every 100 units in, they only get 54 units of actual power out of that system. So now economies are not their biggest concern, but that's a lot of loss, you know, in a pretty bulletproof environment. So how practical is that going to be for commercial airlines, for example? I just don't see that as something functional. And then, of course, there's the classic safety concerns. You know, we go from the space shuttle to the Hindenburg, you know, so I'm less concerned about this myself because I don't plan on riding on a Zeppelin, but it is a concern. But to me, it's more of a concern because if you're actually going to use hydrogen in a vehicle and it's cryogenically frozen or under 10,000 pounds per square inch pressure, you get into an accident, you've got a really explosive situation, you know, just because of the pressure. Not the fact that the hydrogen can catch on fire, because obviously gasoline can catch on fire. It's just that you've got these pressure tanks driving around, and you know, any little bump, it's going to be an issue. Now they say, okay, we could put the hydrogen and somehow infuse it into the metals of the vehicle, and once again, that's all pie in the sky kind of stuff. Show me it's working, and but that part, I just don't buy it. I don't buy it compared to just putting a lithium ion battery in there. Why would you spend all that time and energy on that research when the alternatives are so much cheaper and well proven? So, so now that I've totally trashed hydrogen as a technology, I wanted to bring up a couple of perhaps viable alternatives in my view, where hydrogen might have a role to play. Because as we've said, the cost of the energy input is greater than the value of the energy output. But as we're putting more and more of these renewable technologies out there into the field, there are going to be times when we're producing a lot more power than we have need for. So it needs to be stored in some mechanism. And hydrogen could be one of those, because the alternative is curtailing the power output. So essentially, you're saying that the power input is going to be free. So the economies there change a bit. If the cost of the energy going in is zero, then it becomes a little more viable. So where would something like this be viable? And of course, aviation, as we mentioned, although I think Pete raises valid concerns that that's probably not the best use, and the cryogenically frozen and all of that stuff. Maybe you can turn hydrogen into a liquid jet fuel. That's a possibility. But ships at sea, this one seems like a really good option. If you've got these offshore wind turbines, and these offshore wind turbines are running 24/7, and you can be generating hydrogen on site, and you can have a ship that can pull up and refuel at that wind turbine site without having to come in and dock for fuel. To me, that seems like a super cool idea. And speaking of super cool ideas, I just want to point out that this graphic that I'm using here, I used artificial intelligence to generate that thing. So I'm playing around with AI stuff where I just typed into the little program and I said, show me a freight ship pulling up to an offshore wind turbine, fueling with hydrogen, and this is what we got. So, and then the next one I generated where I said, put a factory next to a solar array with hydrogen storage tanks. And because that's my other alternative, is let's say that you've got a aluminum smelting plant of some sort located next to a big solar array. And when the solar array has more capacity than it has need for at the utility, it can use that power to generate hydrogen, and the generated hydrogen can then run the on-site power manufacturing plant or whatever. And you don't have transport issues. You don't necessarily have storage issues. You're just using what would have otherwise been curtailed and making hydrogen that is then going to be used on site. So I think those are some possible ideas in my mind that hydrogen might be economically viable in those very specific situations, but not as a replacement for generating electricity on a large scale or in vehicles, in transport vehicles. I don't see that as a viable option. So, okay. Well, Tim, did I smile enough there? So, okay. You've got a question, Tim? You're still on mute.
Hi, Jay. How you demonstrated that the space shuttle, they lose all that fuel before they get it into the boosters?
Yeah.
How do they lose it?
It mostly evaporates out into the atmosphere. Have you ever noticed how ice is forming? And a lot of this stuff, hydrogen is such a small molecule that unless it stays below that temperature, it's going to leak through the metal of the tanks. And it's also going to, when you're transporting it from whatever storage facility to the tanks on the shuttle, you're going to lose a bunch of it, just through evaporation. When you're transporting it from wherever it's being stored over to where you're going to be, filling up the tanks on the shuttle, you lose a lot of it then.
Oh.
Have you ever seen when the space shuttle is moved from its storage hangar over to the launch pad? And they do that slow march on some big tractor thing, and it takes a day or so to move it from there to there. It's going to be losing hydrogen through the metal surface of the tank. So they have to anticipate that. I mean, hydrogen is just something that it's hard to store. It's hard to keep it. In fact, think about like a balloon that you fill up with helium. If you do a rubber balloon and you fill it up with helium, within just a couple of hours, it's going to have leaked out through the surface of that rubber balloon. That's why you have to use Mylar balloons and things, because they have a much more compacted lattice to hold the helium, because helium is a pretty small atom, but hydrogen is significantly smaller than that. So if you were going to use hydrogen in one of those Mylar balloons, it would leak through it just like, you know, you were leaking through with helium through a rubber balloon. So
It's hard to comprehend. Think of a gas like that would penetrate through metal.
yeah, and I've talked to some of the natural gas people, and they say, oh, well, we're working on a technique where we can dilute the hydrogen enough that we can use existing natural gas pipelines to transport it, and then we can re-refine it at the other end. And I'm thinking, yeah, okay. I'll believe it when I see it, you know. And I hope I never see it, because I just think it's it's the industry clinging to life and using government research money.
And the industry you're talking about is the fossil fuel industry?
Yeah, for sure.
All right. Thank
Yep.
you.
Anybody
Jay,
else? Yeah.
Jay, I mean, if you look at the technology, let's say solar and stuff like that, right? I mean, the idea is that going forward in the future, we expect PV production of energy to be reduced, maybe substantially, with evolving technologies coming on stream. And that obviously will play into green hydrogen, meaning the production per kilowatt hour, let's say for 1 kilogram of green hydrogen, will be expected to fall, and hopefully fall substantially. Because most of the issues here right now, I'm thinking about, from what we are discussing, is about application, rather than the production. But I don't know. I just think, saying in my back of my mind that maybe seeing in the 5, 8, 9, 10 years time max, we will see some evolution in technology that maybe green hydrogen may make sense. I mean, economically point of view.
Well, I would argue that because of the very nature of the fact that it takes more energy to make the hydrogen than you get out of it, there's always going to be a better alternative for storing that inexpensive energy, whether it's flywheels or water or, you know, heating up sand or whatever. There's a lot of different technologies that do not require more energy in than you get energy out. So I think hydrogen is just, it's theoretically possible, but it is not, it's not competitive, and I don't believe it ever will be. I just don't. Not for general use. For very specific applications, yeah, perhaps, but not for general use applications. So, any other questions or comments before we call it a day here?
Yeah, I have a question. I have one question.
Yeah.
So how bad is it for the environment for all that hydrogen to leak out into the...
I don't think the hydrogen is the issue, because hydrogen, of course, if I recall correctly, is one of the most abundant elements. Obviously, if you get an imbalance going, the biggest environmental issue at the moment is the creation of CO2 in the creation of the hydrogen to begin with, when you're using fossil fuels to make it. But that's the biggest issue. I don't think the leaking out of the hydrogen is the big concern at the moment, but who knows? All right, I want to just remind everybody that we're going to take a month off on this. So see you guys all in the new year. Hope you have a nice holiday, and we'll talk with you in 2024. Amazing. All right, take care. Bye-bye.